now that you're finished with your do now, let us continue with the different parts of this lesson. Um, from time to time, I might, or I would suggest that you should pause the video and afterwards come back. This is not a video where you can finish in one sitting. I would suggest that you should analyze what I'm discussing and at the same time what you are trying to complete and what you are copying from this video. Um, so at this moment, without further ado, we can continue. So let's pause and go to the second page, page 2. So now, page 2. So let's start, or let us continue with our review of the unit of measurements. For those of you who have watched some videos last summer or during the summer on the assignment that I provided you, I have not forgotten that. So let's move on. So unit of measurement. So in science class, in every science class, that includes your most recent one, which is chemistry, or for those of you who will be taking biology next year, AP Bio, or if you have taken those classes with Miss DeAndre or Miss Choa, unit of measurement in science is expressed in terms of what we call the SI system. SI, or System International. Okay. Internationale. Okay, so System International, which is based in France. So SI system. So in science classes, we use the SI system, or also known as the metric system. While in math class, so let's write it down, math uses what we call the imperial system. SI against IS, imperial system, which uses math English units. In math class, you use inches, feet, yards, while in science classes, we use centimeters, millimeters, and meters. So the measurement varies. It's because of the system that we're using. The System International is designed so that makes sure that everybody in the universe, or everybody in the world to be exact, uses the same system of measurement. Now, in the world, it's so sad to say that the United States is one of the very few countries that still uses the metric system. Metric system is still in the United States. That's why you still learn it in mathematics. If you go on the street, it is called miles per hour instead of kilometers per hour. If you're driving by car, or of course, if you're driving and traveling by car, and you are heading north, then suddenly the speed limit change into let's say 100. So it means that you are 100 kilometers per hour instead of 55 or 60 miles per hour, so 60 miles per hour. So meaning you are in a different location and you are in Canada. If you're driving south and then the speed limit changes into 100 again, then we are in what we call Mexico. So the only country in the world that still uses the imperial system is the United States. Other countries who still use them, first one is Myanmar or Burma, one of the in Southeast Asia, underdeveloped country. Another one is Liberia, which is also in, well, close to Asia, but mostly it's from the former Soviet Union. So metric system and imperial system. Now, in metric system, a lot of you might be surprised to know that there is what we call, in the metric system, There's what we call the MKS, and then the other one is CGS. MKS or CGS. So MKS and CGS is represents the three basic unit of measurement or different basic measurement that we're doing. Okay, unit of measurement is MKS and CGS. But what are some of the physical properties that we measure? Basic. Okay, basic physical properties of that we measure. First one is your length, also represented by L, and then later on in our lesson, there's what we call length, which is also distance. Example of length is our distances. There's another one, displacement. So these two are different, but however, they are interchangeable. Okay, distance. Okay, and then there's another measurement that we do, which is mass. Mass is represented by lowercase m, and there's two types of mass. We have the matter, or also known as material. So how much quantity of matter there are. And then the second type of mass is what we call inertia mass. We will learn about the details of inertia mass. So in this class in physics, most of our lesson has something to do about inertia mass. If we're talking about kinetics, that is inertia mass. If we're talking about statics, then we're talking about material mass, because that's the amount of force of gravity. But they're interchangeable because the factor that you multiply to change certain mass into force are the same values. For the seniors who are watching this video, you should remember that mass and weight are not the same. Mass and weight are not the same. For those of you who are juniors, yes, mass and weight are not the same. The last physical quantity that is measured in physics is time. Technically, time should not be considered time, but instead it is period. So period, that's why the symbol is delta t. Time is always continuous. Okay, continuous. So most important thing here is that we're using period. Okay, period that change in time. However, when you change time, it always starts at 0. So when you subtract the if you subtract the initial time, and that will give us 0. So just sometimes we just use t. The shortcut for this one is going to be t minus 0. So therefore, it will still be equal to t. So these are the basic or the fundamental units or physical quantities that we measure. In length, measuring length, we're familiar with inches. Okay, we're familiar with feet. We're familiar with yards. Now, in the metric system, the most common one that we use is the meter. Okay, it's the meter. So that's why it's called M. M is right there. M. Mass is, for this type of measurement, is in terms of kilograms. And that is kg. So K. And then last but not least, the basic unit of time is your seconds, or S. So MKS. So the acronym MKS is basically the unit of the fundamental physical measurement or quantities that we in physics class, or not only in physics class but in science classes measure, okay, physical quantities. Now, what if it's smaller than a meter? So let's say an object is smaller. Okay? So instead of measuring, let's say, an Amazon box, we're measuring a jewelry box. Or instead of measuring, let's say, a cabinet, we are measuring a small, maybe, yeah, jewelry box against a cabinet. So instead of using meters, since it's smaller, we will use what we call the centimeter. And the centimeter is denoted by cm. So this is the symbol. Okay, so this is the symbol for the unit. So when I ask you what is the unit, it's not L, but instead this is your unit. So material, so mass. So if it's very small, then we use what? Grams. And that is G. Of course, time is still going to be seconds, because that's the smallest unit of measurement. There's no smaller than seconds except for millisecond. That is not considered a new unit, but instead it's a smaller of the base unit, which is S. So this is the explanation to what is MKS and CGS. In the future, when you go to college and you're majoring in science or engineering, you will notice that you will purchase books and it says they're MKS units or CGS units. Now let's move on and let's talk further about what I've mentioned just recently about time. Okay. So when you're talking about smaller, okay, so if we're talking about smaller unit of time, then we will use, so time. So what I'm going to do is use smaller. Okay, so when we talk about smaller, so smaller, then we will discuss something about what we call M of S. M of S, which is also known as millisecond. Okay, so millisecond, so it's smaller. Okay, millisecond. So every time it's smaller than a second, for example, in the Olympics, the time difference from the gold medalist from the silver medalist is sometimes in a millisecond, split a thousand of a second. So some would make a wrong understanding from the word milli, that it's a million. That's mega. Okay? Milli is a representation of what we call 1 over 1,000. Okay, milli. Milli is 1 over 1,000. How about if it's 1,000 over 1? It's not a milli anymore, but instead 1,000 over 1 is what we call a kilo, because you multiply it by 1,000, so kilosecond. But in time, in terms of standard measurement, when there's not going to be any measurement that is kilosecond, but instead it's always going to be smaller, and that's millisecond. There's no centisecond. There's no nanosecond. Well, nanosecond do exist now in particle counts and particle acceleration. However, we don't use nanosecond in physics class, physics 1 class to be exact, because we are just learning fundamentals of Newtonian physics. If there will be some lessons or questions in the future that is in nanosecond, so meaning that it's just 1 billionth of a second, because right now in terms of speed of your computer or in the internet, we're talking about and then we also have what we call the microsecond. Okay, So microsecond. So at this point, I would suggest that we pause. Okay, so let's pause and move on to page 3 when we come back. Okay, so now that we are on page 3, here's a table corresponding to the different prefix. For example, as I was mentioning earlier about nanosecond, about kilosecond, or I've mentioned something about millisecond, which is very common. Now this table are just the prefix. However, the most important thing here is that we have the base. Okay, so the base units. So what are the base units? First one is your meters. So that's the measurement of length. Meters. Second one, what's the base measurement for mass? That will be grams. And then the base measurement for time is second. So that is your S. So MGS. So it's, do not get confused about the MKS. Where we're going deeper into understanding what is the MKS, CGS, and what is G, what is M, and what is S. So how do you interconnect them? So again, if you are measuring huge objects, trying to measure the dimension, trying to measure the mass, so if you start using meters, you cannot use grams. Instead, since you use measurement in terms of meters for an object, then you have to use kilograms. So kilograms of water, kilograms of cement, kilograms of concrete, and then time is going to be S. Now, if there are small objects, or if you measure in terms of centimeters, the dimension is centimeters, for sure, the measurement of your mass should be in grams, not kilograms. Now, let us move on. So what is the unit time conversion? So there are 2 or 3 unit time conversions. Of course, the first one is seconds. That's the smallest one, which is your S. You have minutes, and minute is represented by MIN instead of M, because M is for mass. And then last but not least, we have hours, and that is in terms of H. Okay, so this is what we call the metric system. S, mean, H. Now, trivia, if you go to your math class, you don't use S, mean, and H. But instead, if we're using the imperial, also known as the English system, so second is represented by SEC. Minutes are the same, min, and then hours is HR. So these are the difference. Okay, math class, science class, math class, SEC. However, whatever the difference on the way you represent the symbol of the units, the dimensional analysis or the conversion factor will still be the same. Will still be the same. But these are different color pens, so I can emphasize. Okay, so dimension or conversion factor. Okay? The physical measurement. So when I say 1, so how many seconds are there in 1 minute? So there are 60 seconds is equivalent to 1 minute. So we're all familiar with this. And then if I say, let's say 60 minutes, that is equivalent to 1 hour. Okay. 1H. 60 min is 1 hour. Okay, I just accidentally put the dot. That's not part of the notes. 1 hour. So 1 hour is 60 minutes, 1 minute is 60 seconds. What if, okay, what if the question is asking you. So in physics class, the most common thing is that you change the speed of a moving body from kilometers per hour to meters per second, and meters per second to kilometers per hour to check if it does make sense. Um, what will be 1 hour in terms of seconds? So 1 hour, how would you make it into seconds? So all we have to do is to convert 60 seconds into 60 minutes. So if you multiply those two values, 60 times 60 will give you 3,600. Yes. 3,600 seconds is equivalent to 1 hour. So this is your 1 hour of movement. So 1 hour. In the succeeding page, I will go over quickly on how to convert units. So let's pause for the meantime and let's move to page number 4. Okay, so now let's continue. Again, most of you watched the video last summer on lesson on how to do conversion. So again, I just want to demonstrate again on how to convert different units. Okay, first one. Let's say you were given the task to convert 15 meters. Okay, so that's 15 meters, converting it to in terms of centimeters. So how many centimeters are there in 15 meters? What is the first step? Step number 1 is to make sure you copy this unit or copy the given information. So step number 1, that is 15 meters, followed by changing it into a fraction format, but it does not change its value. So this is your magnitude, this is your unit, so you divide it by 1. So every time you divide a number by 1, you're changing it into a fraction. However, well, it all the time it do exist. Like 5 meters per second, there's always a divisible 1 at the bottom, but that 1 can be ignored because anything divided by 1 will give you the same number on the top, which is your denominator. So 1 over or 15 over 1, and then you draw your multiplication symbol, followed by vinculum. That's by the way, that's how you call it. The line on a fraction is called vinculum. Just a trivia. Now I want to cancel meter. Therefore, I will place meter at the bottom part, which is the inverse or the opposite side of our fraction. Opposite side of the fraction, so that's meter. You cancel down meters. And then we put our final destination. We want the answer to be expressed in terms of centimeters. So therefore, if I multiply this by any number, it will give me an answer that is in terms of centimeters, because that's already centimeters right there. Now, if you look at table number 3, or the table in page number 3, which one is bigger? Meter is bigger because that's the base unit and centi is on the bottom of the base. So therefore, for every 1 meter, there are about 100 centimeters. So 100 multiplied by 15 will give us 1,500 centimeters. So all you need to do now is to simplify it. Either use a calculator, or if you can do your mental mathematics, that will be easier. Okay, that will be easier. Now, if you still don't get it, okay, so I will give you another example, but this time the example is a little bit much more complicated. Let's do a little bit more complicated stuff. Okay. Let's talk about distances or displacements. So let's start by converting kilometers to centimeters. Okay, so kilometers to centimeters. Why don't we use that one? So let's say I have 1 kilometers, and let's change change this into, I want to change it to centimeter. So this time it's going to be smaller. Okay. So if you look at your table in page number 3, there isn't any. Okay, let me just pull it out for you. Let's put it out. There isn't any conversion straight to. It's always from base to certain steps. Isn't any number divided by the one on the top, or 1, or that conversion numerical value divided by 1, which is your conversion factor. So there isn't any conversion factor that jumps from kilo going to centi. Now, how do you think you're going to address this kind of concern? Okay. Of course, let's do it one step at a time. Okay. To some, you want to rush things, but I would suggest do not rush, but instead, let's focus on doing one step at a time to make sure that things are less complicated for us. Okay, so kilometers, there are how many kilometers in your base? Okay, so let's start by copying our unit, our given information, which is 1 kilometer. Our next step is to convert this into fraction by dividing it by 1. So 1 divided by 1 will give us 1. Draw our multiplication symbol and change our kilometers into something. Just like what I mentioned on the table, there isn't any conversion that says 100 over 100 or 1000 over 1000 or 100 over 1000 or 1000 over 100. Okay. Instead, we will go to 1 all the time. So what is that 1? That's your base unit. And what's the base unit for kilometers? So now kilometer cancels out. So we have the base unit of meters. And we all know that there is 1 for every 1 meter or kilometers. There is an equivalent of 1000 meters. We can stop here and finalize the answer. No, we're not, because we want to convert this to centimeters. So let's put another 1, another vinculum, and then let's place meters on the bottom so we can cancel it because that's on the opposite side, and then replace it with centimeters. Now it's a centimeters, so if I'm going to look at all my calculations right here, there's no more other unit except for centimeters. So for sure, I will get an answer that is in centimeters if I know the conversion. But we all know that meter is bigger than centimeter, and there are 100 centimeters in 1 meter. So if you multiply 1000 by 100, so that will give you 100,000 centimeters. So that will be the final answer for this question. So final answer for this question. Now I'll give you one more example. Again, for those of you who have not watched the video or from the assignment from summer class, from last summer, it's not a mandatory thing. I just posted it there so that you could practice and you can improve, you can hone your skills in conversion. So next one, how about if I give you a compounded unit? It's not a direct unit, but instead it's an indirect unit, something that you develop, and that is 5. Okay, so I want you to change 5 kilometers per hour into meters per second, m over s. Meters per second. So meters per second. So kilometers per hour to meters per second. Kilometers per hour to meters per second. So now, first step, of course, is to copy down the unit, or copy down the given, which is 5 kilometers per hour. But if you look at it, this is already in fraction, so all we have to do is divide it by 1 again. Just put the 1, that's already in terms of fraction. So meaning, your kilometer is on the numerator, and your hour is the denominator. So this one is very easy. Its fraction is already there. Okay, so denominator, numerator, numerator, denominator. So I can say, okay, so let me just rewrite it because I did put some annotation. So kilometers per hour. Multiplication symbol, the vinculum or the bar. So which one do you want to convert first? Kilometers to meters or hours to second? Doesn't really matter which one goes first. It will all come up with the same answer later. Now, why don't we convert kilometers first? So let's cancel kilometers. So let's move kilometers in the bottom. So your kilometer cancels out. And we want to change it to a base unit of meters. Meters, that's meters. Okay. What is the conversion factor? There are 1,000 meters according to the table in page 3, 1,000 meters to 1 kilometer. Now let's convert our hours into seconds. Since hours is in the denominator, let us convert or let us cancel hours by placing our hours in our numerator. So hours cancels out, so now we have seconds in the bottom. So meters over second, that will be your desired answer. So 3,600 seconds is equivalent to 1 hour. So all I have to do is calculate using your calculators. Okay. To most of you, you will use your 1.39 meters per second. You will use your phones because most of you are familiar using your phones. However, I would not suggest that. Instead, invest on a calculator that you can use during the test. It's a calculator that you use every single day. It's a calculator that is, I wouldn't say cheap, less expensive, somewhere like $20 to $30 range. Sometimes they also sell it in the dollar store, but unfortunately, the dollar store do not exist anymore. Just buy the Texas Instrument, the basic one that you always see inside the classroom. Now, what if I decided to use to convert hours before kilometers? Will it give me the same answer? Just for the sake of just showing it to you guys. So 5 kilometers per hour, so that's already a fraction, times, let's say I wanted to change my hours first instead of kilometers, that's seconds. So 1 hour and hour cancel out is equivalent to 3,600 seconds, times, now let's change kilometers. So kilometers is the numerator. Now let's place it in the denominator. And then let us change it into our desired answer, which is in terms of meters. So we have 1,000 meters over 1 kilometer. It's the same thing right here. 1,000, but 1,000 just came second, while 3,600 came first. In the first solution, it's in the second step. Now, according to the commutative property of multiplication and addition, it doesn't matter. It's like 2 divided by 2 is still going to be 1. I'm sorry, 2 times 2 is equivalent to 4. Or 1 times 2 is equivalent to 2. 2 times 1 is equivalent to 2. 2 plus 1 is 3. 1 plus 2 is always going to be 3, as long as the integers have the same signs. So kilometers cancels out. So 1,000 times 5, so that's 5,000 divided by 3,600. So that will give you an answer of 1.39 meter per second, or that is 1.3888 repeating. So that's why let's just round it up to the closest, or round it up to the closest whole number. Now, let us move on to the next page, page 5, and that is an introduction to scalar and vector quantity. Okay, so let me just pause and move to the next page. Okay, so now let's talk about vectors. So when we talk about physical quantities, there's two types, vectors and scalar quantities. Okay, vectors and scalar quantities. In physics class, most of the time we are discussing something about vector quantities and scalar quantities. Now, sometimes they are not interchangeable. Okay. Later on, you will know that since our topic is all about rectilinear motion, so that's why velocity can be interchanged with speed. Speed can be velocity. However, if it's very specific about displacement and distance, there's a big difference between the two, then it's something that you will need to analyze later and to make sure that you know what type of quantity are you really measuring. Is it the vector quantity or the scalar quantity? So let's start with the word magnitude. I know most of you would say, oh, magnitude. So we're talking about earthquakes. Yes, and that's why I use this example. 6.5 earthquake is a numerical value. That's the magnitude. The magnitude is 6.5. So it's basically the base, the size or extent or numerical value. I think I mentioned in regular physics class or physics of the universe class that it is the amount. Yes, it's correct. It's the amount. For example, 6.5 earthquake. What if I change that 6.5? That's still the magnitude, but because of the change in units, and that we learned from the previous lessons, let's say 6.5 kilograms. Now we have, how about if I will discuss about 6.5 newtons. So most of the seniors who are taking this class, they know the difference between these two units, or not units, but to be exact, these two values or two quantities. 6.5 kilogram, they will say, oh, that's the mass, while 6.5 newtons is the weight. Again, weight is not mass, mass is not weight, and we will learn that later. Now, alignment or orientation is your direction. So direction, so there's two things that you must remember, magnitude and direction. You look at the value of that quantity. So for example, 6.5 kilogram is their direction. Okay, is their direction. But sometimes it doesn't really matter. Okay. How about this one? Is their direction? The senior class, our senior students, they would know that newtons, there is a direction. What if I say negative? What is the direction when it's negative? Or, let's be very specific. Let's say I have 6.5 meters per second before we move on to directions. 6.5 meters per second. And now we have what we call 6.5 meters per second. However, this one is positive. Okay, positive. So which one has a direction, which one don't have a direction? Okay. How about if I put this one right here? So those two lines in between. So you put the number in between those two parallel lines. So this is an absolute value. So definitely we're just talking about the magnitude. We don't care about the direction. Now, in terms of the direction, it's very easy. Okay. Very simple. So we have this, this, and this, and this one. So we have north, east, south, and then we have west. Okay. In math classes, we don't put NESW, but instead this is first quadrant, so this is your 0 degrees, and right here is 90 degrees, and right here on the other end is 180 degrees plus 90. So I'm going down is 270 degrees. And then another one is when you complete the revolution. So this is something that you're most familiar with, and that is the 360 degrees. So those are the directions, or the bearing, the location of it. But be careful, because there's what we call frame of reference. Okay, frame of reference includes two things or three things: the starting point. Second is the initial time, so that you could figure out if an object did change position at a certain point in time, so it does not violate the law of physics. So you can be happy to say that it's moving, or the object is changing position, or the object is moving. So scalar quantity is described by magnitude only. So there's only magnitude, there's no direction. So these are what we call the scalar. So be specific about this one. Scalar quantity, since direction is not given, it's either not important or the direction could be changing. That's true. That's why I mentioned earlier, if it's a rectilinear motion, so we don't really care about the direction. So we can interchange the velocity from speed. We can say the speed is also the same as velocity. However, if it's very specific, then we have to mention it. One example of a continuous changing motion is a circular motion, where it's going around in circles. So the direction changes. The direction changes, and that's when we have what we call the centripetal acceleration, because it is being caused by centripetal force. The centripetal force prevents the object to move on a straight line, because according to Newton's first law, or first law of motion, or also known as the phenomenon of inertia. The phenomenon of inertia would states that an object that is moving will continue to move in a straight line at the same speed unless acted upon by unbalanced force. And that is the presence of centripetal force, because of the word centripetal, meaning center seeking. So it will always go to the center, preventing it from going outward on a straight line. Okay. Scalar. So here are some of the examples for scalar. And let's use 5 kilogram. Okay. From our previous pages, what is kilogram? That is a measurement of mass. Okay, so mass is kilogram. How about 5 meters per second? 5 meters per second, so we don't care about the direction. So that is your speed. Meters per second. What if I have what we call 5 meters? 5 meters, there's no direction mentioned. There's no direction mentioned, so this is what we call distance. Okay. So distance, mass, and speed, these three are example of what we call scalar quantities. Temperature, if you want to add temperature, temperature is also a scalar quantity because there's no direction. Vectors. So vectors. It is a physical quantity where direction do matter. Okay. For example, I would say -5 newtons. So -5 newtons, it's going down, so meaning this is your weight. So weight is basically newtons. Weight is not mass. Mass is not weight. They are interconnected with each other. And there's two types of mass, and that is the inertial mass and the matter mass. Okay, material mass. How much molecules, or how much of the materials there is in that certain substance. Second, what if I say 5 meters per second? 5 meter per second, and then I would say east. Okay, so 5 meters per second east is also equivalent to 5 meters per second, and Let's use the direction right here in the table. So if we say east, what is the angle? So direction to the right is also known as 0 degrees. And 0 degrees doesn't mean that it's 0. It's just the location. So there are some values that are 0, of course. For example, if you figure out the y component of a 0 degrees is going to be 0. That's why cosine is not going to be 0, because cosine is the x component. There will be an inserted video, okay, about a review on trigonometry in this session. Okay, so you might need to review trigonometry because it's essential to know trigonometry and physics. So these two values right here is called the velocity. Okay, velocity, which is denoted by letter V, italic V. So italic V with an arrow on the top, meaning it's a velocity. But it doesn't mean that it needs to be opposite direction in terms of the arrow, just because it's negative. No, it's always denoted with an arrow going to the right, because our equation always points to the right side. Last but not least, what if I say distance of 5 meters positive? 5 meters positive. So that is also considered as your, instead of distance, this time there's another word, and that is called displacement. So if you notice, these two over here are interconnected with each other. They're similar, but they're not the same. 5 kilograms, 5 newtons. This one is weight, this one is mass. The unit will tell you which one is weight, which one is mass. The unit dictates the value of that magnitude. The amount that we're saying does not matter unless you know what is the unit. 5 meters per second is 5 meters per second. So it's specific in a storm. So if you watch those news about hurricanes, oh, Hurricane Andrew is traveling 50 miles per hour northeast due north, or northeast due east. There are some explanation to that later. That's a direction, so that's a velocity. That's why in the first day presentation, I said it there. It's exciting because the speed about cars is the same speed and kinematics knowledge that we use for tracking storm. Last but not least, displacement. Sometimes the displacement is 0. Okay, displacement is 0. The units with the direction changes everything. So that's why we need to be careful. So what I'm going to do is to pause for today's lesson. I will upload additional videos about this topic, including the topic on the trigonometry, the review of the values in trigonometry. What I want you to do is to make sure that you register in Google, not in Google Classroom, but AP Classroom for the test. Okay, for the test for 2025, and at the same time, so you could start working on the assignment that I will be posting for you guys. So there will be a first assignment and all about vectors. It is all about vectors. So you can start looking at the assignment. Usually when I put those assignments, you have the whole week to try and figure out the correct answer by going over the lessons. Again, physics is not a class that you cram every information in one night and hope that you learn it. Okay, see you in the next video for additional information. So we can move on to page 6 onwards with different examples and additional lesson.